Look at Get VPN, VRF aware VPNs. If you get a chance, we'll take a look at VPNs using certificates with a router as well as a CA server. But as long as we can at least finish up on Get VPN with VRF aware VPNs, I'm good with that. The plan for this weekend is to knock out these topics over here. Let me just bring my marker. So we will make sure we do Get VPN, complete it off. VRF aware VPNs, we'll take a look at it. We might do that today or tomorrow. And then for tomorrow, we also have IKV2. Most probably, I'm going to do VPN certificates, IKV2 VPNs tomorrow. All right. 1 second. Record. Okay, everybody should have it by now. Yeah, but I gave it to you as well. So the plan is Get VPN, VRF aware VPNs, and we will take a look at SVTIs. Fahad, can you hear me? Everybody should be able to hear me, right? All right, good. So that's a plan for today. With that in mind, let's get started. So as I said, today we'll take a look at Get VPN. I'll do VRFs for the people that don't know what VRFs are. And then we'll take a look at Get VPN. Do this as site to site. So we do have a bunch of stuff to do today. And we'll do Get VPN VRF based. So a lot of, do it like this, VRF aware. This is the stuff for today. Tomorrow we'll take a look at router as a CA server, CA based VPNs, and then we'll take a look at IKV2. That's for this week. And the following week, which is next week, we will finish off our VPN section by taking a look at FlexVPN, DVTI SVTI based site to site, and DVTI SVTI based spoke to spoke using NHRP. That's next week. So next week we'll be done with our VPN section. We'll get started with the firewalls. Any questions so far? All right, with that in mind, let's get started with Get VPN then. What is Get VPN? Get VPN is a VPN that allows you the ability to set up a multi-point IPsec VPN. It allows you the ability to have a VPN where you have a single key that is being used by multiple devices. So it is a multi-site IPsec VPN. Uses a single session key for multiple sites. All right. It has two entities. One second, guys, need to give record permission. Anybody else need record permission, guys? Done, everybody? Okay. All right. Prashant, I'm sure you would need permission. Guys, try to join in on time, because then what happens is I need to go back and give record permissions. So it has two entities. One is called a key server, and the other one is called a group member. All right. Now, the way it works. This is the type of VPN that you have two main objectives over here. Number one is to do efficient forwarding, and I'll explain how it does that in a bit. And number two is centralized configuration and control. These are the two main objectives of a GetVPN. What do I mean by centralized configuration and control? The way it works is it is based on a premise of a device known as the key server. Although the name key server implies that it is a server, in reality it's not a server, it's just another router. The function of this router is to create the session key and exchange it with all the different devices that actually are going to be doing the encryption. It is also the device that will be used to configure all your interesting traffic ACL. It is also the device that will be used to configure your transform set. So what happens is you configure all these different parameters on your key server. You have another entity that is actually responsible for doing the encryption. So let's say you had 4 different sites connected over the cloud, the service provider network. Let's say router 1, router 2, router 3, and router 4. The actual encryption will be done between router 1, router 2, router 3, and router 4 to encrypt, let's say, their LAN segments, these LAN segments. All the configuration will be done on the key server, and it will be downloaded. That includes your session key, your interesting traffic, your transform set will be downloaded to router 1, to router 2, router 3, and router 4. So all 4 routers will get their configuration from the key server. All right? So you don't need to configure all of these parameters where? On these devices over here. They're all configured on the key server. These devices that will actually be doing the encryption based on the session key using the interesting traffic and the transform set are known as group members. As PR the device, it should be OL, meaning English, please. Say that again. It should be only routers or a mix of routers or firewalls. No, this is only on routers. GetVPN is only on routers. So the capability of running GetVPN is only on routers. So do you understand this concept over here? So you have a key server that will be used to configure all the interesting traffic and transform set, the session key. It will be downloaded to the routers that will be doing the encryption. That is router 1, router 2, router 3, router 4 in our case. Okay. And they will be the ones that will be doing the encryption. Good so far? All right. The other thing that I also want you guys to understand about this is the way it works, and that's very important to understand. Do you guys remember when we did IPsec? Good question. Can router 1 be the key server for the example? The answer is no. The router that is acting as a key server cannot be a group member or vice versa. So they need to be on separate devices. So let's say, coming back to that example that I showed you over here, let's say you had a headquarters site. That is the one that will be housing the key server. And it also has a router that will be encrypting. So in that case, you would have two separate routers. One will be the group member for that site. So this is the headquarters site over here. You'll have a key server as a separate router and a edge router, which will be your group member, which will be a separate router. So they cannot be on the same device. So they have to be on two separate devices. Got it? Everybody understand that? That's a good question because that basically is a requirement in terms of when you set it up on your site. Now, at the same time, what's the purpose of GetVPN? Why do they go to GetVPN if they had the other type of VPNs already there? The main reason is to make it a little bit more efficient along with the centralized configuration. What do I mean by make it efficient? When you took a look at your IPsec header, you had an inner device or inner header, let's say 10.1.1.1 and 10.2.2.2. And then you would need to put an outer header, which was a process to figure out what is the outer header to put it over here, right? So the mapping needed to be done. This would be the public address for the corresponding private addresses over here, right? In GetVPN, you still, because it's IPsec, you still need two headers. But what it does is it says, I'm not going to do any mapping. My objective over here is just to encrypt. So whatever is on the inside, I am going to use that as my outside header as well. I am not going to do any type of mapping. Whatever my inside header is becomes my outside header. If this is my outside header, what does that tell you about this header? That means this is on the outside of the packet, right? If it's going over the internet, will it work? Will this work over the internet? No. It's a private address. So what does that tell you? GetVPN is not really meant for the internet. So if I'm not going on the internet, why do I want to encrypt? Let's say I have an MPLS set up. Connecting my sites to each other. It's an MPLS VPN. This is your service provider network, which is connecting 4 my sites to each other. This type of network is called a private WAN. And the service that I have is an MPLS VPN type of setup. Or in the older days, a frame relay type of setup or an ATM type of setup. When I'm sending my traffic in an MPLS network from this guy over here to that guy, or this guy to this guy, is that traffic which is traversing the service provider secure? It's not. It's clear text. You get my point? So GetVPN's main objective was not to do routing, which the other IPsec VPNs are doing. Yeah, route leaking that can get the packets. Not even that. Even if there's no route leaking, I would be able to look at the packet because an MPLS VPN packet is clear text. So somebody sitting at the service provider will be able to look at that traffic. All right. The purpose of GetVPN is not to allow you to do routing as well as your encryption. The purpose of GetVPN is to make sure that the traffic that is getting routed already has the ability to get encrypted. So I'm going to take the focus of the routing completely out of the IPsec portion, just focus on encryption. So that basically means as a prerequisite, before you set up GetVPN, you need to have a fully routable network. So you need to have end-to-end reachability prior to doing the GetVPN. The only purpose that GetVPN serves is to encrypt, but by doing encryption on this type of fully routable network, it is the most efficient way of doing it because I don't need to worry about routing at all. Routing should have been taken care of. So one of the most commonly used implementation of a GetVPN setup is on an MPLS VPN network to secure an MPLS VPN network. It's very important to understand that. Why do I need to do GetVPN if I already have DMVPN? The purpose of doing GetVPN is to make it a very efficient encrypting technique as long as I have full routing capabilities within my network, and that typical example is the MPLS. So what does that mean? Can I use GetVPN on the internet if I want to? The answer is yes and no, depends. I can use GetVPN on the internet if I chose to use public addresses on my inside network. Let's say this is my inside network and I'm using 199.100 over here. This is my public network. This site has 200.110. Now I do have the capability of allowing this guy, and let's say this is another one which is also connected to the internet. These are all public addresses. So I've not done any type of private addresses on the inside. If I have this type of setup where 199, 195, 200 are all fully routable on the internet, I can use GetVPN on the internet. But what are the chances of you running into sites that have completely private addresses on the inside? Very slim. You guys agree? You don't have too many addresses, too many networks that have public addresses on the inside. So that's the reason that you don't use GetVPN on the internet. Can you use it? Yes, but highly unlikely. So the purpose of GetVPN is to use it on the private WANs. What is a private WAN? What's an example of a private WAN? The most common example of a private WAN in today's day and age is your MPLS VPN network, your L3 VPN network. Not even L3. L3 is your internet. You would say your MPLS VPN network, or the newer technologies that are coming out, VPLS, you have Q&Q tunneling, L2 VPNs, all those you can use SD-WAN, you can use GetVPN to encrypt. All right, good so far? So with that in mind, let's write the notes and then we'll take a look at the configuration. It has two entities, the key server and the group member. All the configurations are done on the key server and downloaded like what, Om Prakash? To the group member. It cannot be a key server. I already answered that question. But it can be doing other things. It can be a router. It can be doing a DHCP server if that's what you're looking at. It cannot be a group member. All the configurations are done on the key server and downloaded to the group member. Done. The group member, the key server, and the group member need to be separate devices. GetVPN copies the inner header onto the outer header. It will work only on fully routed networks. Potentially can work on the internet, but only if you are using public addresses on the inside. Good? Clear so far? Everybody okay with this? Now, who generates a key? The session key over here. Who's responsible for generating the session key over here? The key server is. It needs to send the key server to whom? So that they can do the encryption of the actual data. It needs to send the key to the group member. The group member is going to be having the actual LANs that it needs to encrypt, generally your edge devices, towards the other side. So if that's the case, I need to send the key, not only the key, generally in ISACamp, I would just send the key across, the session key across. But in this case with GetVPN, I'll send the session key across, I will send the ACL across, and the transform set across. To whom? To the group member. The group member gets that information and uses that information to do the encryption, the appropriate encryption. So the key server needs to set up a relationship between itself and all the different group members and download the session key, the ACL, and the transform set to it. Where is the session key exchanged? What phase is the session key exchanged in? The session key is exchanged in phase 1. It's used in phase 2, but it's exchanged in phase 1, right? Along with the session key in phase 1, I also need to send the ACL and the transform set. So phase 1 will be set up between whom? I need to securely exchange my session key, my ACL, and my transform set between the key server and the group member. So I need to set up phase 1 between the key server and the group member. You understand that? So I still need to have phase 1 parameters defined on the group members. But the thing about that is, in a normal phase 1, which is ISACamp, what is the only thing exchanged? What's the only parameter that is exchanged between the two entities in normal ISACamp? The session key. Okay, what am I exchanging over here? I'm exchanging the ACL as well as the transform set, not just the session key. So what they had to do was they had to modify ISACamp a little bit and come up with a newer protocol, which was a variation of ISACamp, although it was like ISACamp, that allowed me to exchange the session key along with the ACL and the transform set, because the ISACamp protocol would only exchange the session key. That protocol is called GDOI, Group Domain of Interpretation. ISACamp is UDP 500. This GDOI protocol is UDP 848. It is a variation of ISACamp. It's like ISACamp, plus it also does ACL and transform set. So phase 1 is not done by ISACamp. Phase 1 over here is done by UDP 848. The protocol name is GDOI, which is an extension of ISACamp. So once phase 1 is done, what do the group members have? All the group members have what? The same session key, the transform set, and the ACL, which is required to encrypt the traffic between them. They're ready to set up their phase 2. Phase 2 is to encrypt data. Where is the data going from? Which device to which device? between GMs. Only. So phase 2 is only set up between what? The GMs. So in GDOI or in GetVPN, phase 1 between key server and group members, phase 2 between group members and group members. Everybody okay with this? Questions, guys? Everybody fine before I start the configuration part of it? Anybody require record permission? I think everybody is recording. So it should be good, yeah. All right. So what I'm going to be doing over here is I have this type of setup over here. Forget about this part. I'm going to concentrate on routers 1, 2, 3, 4. Router 6 being your service provider and 7 being the key server. So what I'll do is I'll turn on my devices. Look at the diagram and create a snip of it. Save it. Come on. Should have done it the other way around. There you go. So in this particular network, this guy over here is my service provider. If there are 2 routers at each GM headquarter branch, can it be configured in HA? Yes. Understand the concept first before we go into complexities. Makes it easier on yourself. Once you understand how it works, then you can complicate it and do the 007 stuff with it. Don't clutter your mind at this time. Now over here, I'm going to make this into the key server. This is your group member. Let's call it 1. We'll make this into group member 2. Three, and 4. Good. That's what I have now in terms of my networks. Let's say I have a LAN over here, 10.1.1.0. This guy over here is 10.1.2.0. I have 10.1.3.0. And I have 10.1.4.0 over here. These are my LAN segments. Behind each one of those sites that I want to encrypt. So my interesting traffic should be from 10.1.1 to 10.1.2 to 10.1.3, 10.1.4, all of them. That's my objective over here. Good so far? Let's set this up. I'm going to bring up 1, 2, 3, 4, 6, and 7. I'll just bring up everything till 7. And then we will figure out which ones we need. So these are my routers. While it's coming up, let's also put some networks. Don't forget, these are what type of networks? These are all going to be private networks. I'm not on the internet over here. I'm all completely on a private network. So 192.168, let's call this 17.0. This network is 192.168. Let's call this 10.0. Between 1 and 6. This guy over here, we'll call it 192.168, 20.0. One 192.168, 40.0. One 192.168, 30.0. All right, these are the different networks that I have. If you take a look at R6, E01 connects to 1, 2 to 2, 3 to 3, 1, 0 towards 4. So first thing I'll do is I'll configure my service provider network. This would generally in real life be your MPLS cloud. So I'll call this the ISP. No IP domain dash lookup, line con 0, log 6. Okay. Interface E0/1, IP address 10.6. E02 is 20.6. This is 30.6. (1/0) is 40.6. Make sure these interfaces are up. Router edge IP 100, no auto. Network is 10.0. This would be my service provider done. Let's go to the first GM. No IP domain dash lookup, line con 0, log sync. Okay. E0/0 would be 192.168.10.1, which is towards the service provider on router 1. Router 1, by the way, if you just want to take a look at it, is the network between R1 and R6. Everybody okay with that? The other network is 17 between E01 of R1 towards 7. 17.1 is what I'm going to call it, and then my loopback, which will simulate my LAN segment. So E01, 17.1, my loopback, and I'm going to run my routing protocol. 10.0, 17.0, and my network 10. show IP route, EIGRP, I see those 20, 30, 40 networks from the service router cloud. Router 2, which is my second site, (20.2), my loopback 10.1.2.1, and my routing protocol. (20.0) and 10. So now if you take a look at your EIGRP, I see 10.1.1.0 getting advertised. The rest of the networks are also getting advertised. Moving on to number 3. (30.3). This is done. So again, let's check the reachability. I have 10.1, 10.2 all there. I should be able to ping 10.1.1 from 10.1.3.1 and 10.1.2.1 from 10.1.3.1. So router 3 is done. The next router is router 4. (40.4). Router EIGRP. So now if you take a look at it, (10.1.1), 10.1.2, 10.1.3 all is there, and my key server now. (17.7), and just run EIGRP over here. Should learn all the routes, should have full reachability now. There you go. What I want to do is, should be able to ping 10.1.1, 10.1.2.1 from 10.1.1.1. I want to make sure everything is pingable prior to doing any VPN. So what's a prerequisite for setting up Get VPN? Make sure all networks are reachable, because that's the whole purpose of Get VPN. I don't want to be involved in the routing portion of it. I'll just make sure you encrypt. The routing should be taken care of. Understood? Everybody okay with that? So don't try to run this on the internet. It's not meant for the internet. Clear, guys, everybody? Good. Okay, now let's start doing the VPN portion now. Key server configuration. Phase 1. What did I tell you about phase 1? Does the key server require phase 1? Yes, it does. What protocol is used for phase one with the key server? GDOI, right? Which is an extension of ISACEM. So although it is GDOI, it is UDP 848, but the commands that you put in are still all based on the ISACEM protocol. So you're not going to use ISACEM, but the foundation is still ISACEM. So the commands for phase one remain the same. So crypto, ISACEM, just what we did the last time around. Auth pre-share, hash MD5, encryption, let's say triple des, group 2. Then my key. And the IP addresses of all my group members, 10.1. You could technically put the 0000 over there, or I'm just doing it specifically to those, but you don't really need to. You could say 0000. Everybody okay with phase one on the key server? You guys recognize it? Good. Let's move on to phase two. Phase two, there's no difference whatsoever. I need to define my transform set just like normally I would. Let's say SHA and HMAP. All right. Step 3. Do you remember how in DMVPN we configured the IPsec profile and attached the transform set to it? We'll do the same thing over here. Whatever you want to call it, let's call it iProf set transform set ABC. So the IPsec profile over here contains your transform set. I'm going to use that later on. Anything new so far? You guys understand these commands and the concepts of these commands? All good so far? All right, good. Number 4. Configure the interesting traffic ACL. Now, you have two options over here. One, the one that if you're working as a consultant will get you more money. How many different networks do you have over here? This ACL that I'm going to be creating on the key server needs to accommodate all of those different flows that you have. If you're working as a consultant, this is the way you would do it. Because it looks complicated, it'll take you more time to do it. In here, let's assume this is A, this is B, this is C, and this is D. When I create the interesting traffic ACL over here, I need to write an ACL that encrypts traffic from A to B. Because the same ACL will be used by everybody in the group, I also need B to know that it needs to encrypt traffic from B to A. It needs to have an entry from A to C and from C to A. It's the same ACL that is shared between all of them. A to D, D to A. Okay? 0000 is wrong because you also have some traffic that is going from the outside interface, because I'm going to be applying this ACL to the outside interface for routing purposes or non-get VPN purposes. So 0000 is wrong. But what you can do, this is what you would do if you want to be very specific. This is not it. I not only need to take care of A, I also need to take care of what? B to C, C to B, B to D, D to B. This is where, if you want to make it more efficient, you need to have a good IP design. If you take a look at the IP design over here, what I did was I set my first 2 octets, all of them to 10.1. So if you have a good design over here, what I could technically do in the ACL is say 10.1.0.0/16. Any traffic that has 10.1.0.0 in the first 16 bits going towards any address that's 10.1.0.0 should be encrypted. That will accomplish all of my traffic. You understand that? Sinan, this is a better way of doing it. You're on the right track, but you went a little too far ahead. Understood? But again, that all depends on how good your addressing scheme is. This is known as a summary ACL. Everybody okay with that? So rather than writing a big long ACL, as I said, it's good if you're a consultant because it makes it look more complicated and you get paid more because you're getting paid by the hour. A better way of doing it is this way. Access-list 101, permit IP 10.1.0.0, 10.1.0.0.0.0.255.255. Everybody understand that? So I have the 4th step, which is the ACL. So right now I have these 4 steps on their own. Have I done anything new that you haven't seen before? Aren't these the same steps that I have been using in the past? That I used last week? Everything the same. Now the difference comes in. This is where the actual get VPN configuration comes in. Configure the GDOI group configuration. This is where you're going to link all this together. The way you start that off is by saying crypto GDOI group and a name, locally significant. All right, this name over here is locally significant. I can call it whatever you want. Sales, for example, just a name. All right, in there, first thing that I will do is I'll specify what is known as the identity number. Identity number is a number that the group members will use to identify themselves to the key server, because the same key server can act as a key server for different groups. All right. So when a particular group member comes up, he says, yes, I've authenticated based on phase 1. This is my identity number. And based on that, the key server will push down all the parameters pertaining to that group. So let's say the group number I want to use over here is 111. Just a number. But I need to match this number now on my group members when I go to configure it. Now, in terms of GDOI, am I a key server or a group member? I am the key server. So what I would specify over here is server local. Local means I am the key server. Whereas on the group member, I'm going to point towards the key server. I'll show you that in a second. So if I'm the key server, I need to define the parameters now. I'll create a security association over here, which is called SA, Security Association for IPsec, sequence number 10. Profile. What was the name? iProf. And the match address, IPv4, the ACL name was 101. Identity number is used to when the group member logs in and tries to access the key server. The same key server can be used as a key server for multiple different devices or different groups. So based on the group number, I will identify which ACL and which profile needs to be downloaded to. So the same key server can be a key server for multiple groups. Let's say marketing, finance group. So you have the ability to have different profiles, different transform sets, and different ACLs with different IDs, and they would match over to the identity number. Good. So what I'm saying is whoever comes in based on identity number 10111, I'm going to give him the profile based on the transform set, and the ACL is going to be 101. That is 10.1 to 10.1. Good. And they point to me using an address of 192.168.17.7. That's my address. So the address over there is my address. And that's the entire config for GetVPN on the key server side. So the first 4 steps, step 1, phase 1, the normal ISACM parameters. Phase 2, normal transform set. Step 3, link the transform set inside a profile, because I'm going to call the profile inside my group configuration. My ACL, again, I'm going to call the ACL inside my group configuration. Then I create my group. In there, I identify the group ID, which is the identity number 111. Server, local means I am the key server, and I'm creating a security association. In that security association, I have, for this particular transform set, for this particular ACL, I'm going to use this particular transform set. And they point to me using 17.7 as the address. All right. Copy. Let's go to R7. R7 is going to be my key server. I guess the GM accesses the key server only when establishing a session. Does the key server push updates to GM and they? Okay, initially, hold on to that question, Oscar. I'll tell you when it accesses and what happens after that. But in terms of establishing a session, it happens as soon as you apply a crypto map to the group member. We'll get to that. So at this point, I've configured my key server. Let's go back to the key server over here. Again, take a look at it. Phase 1. Phase 2. The profile attaching the transform set, my ACL, and all my parameters. Once this is done, I'll go to router 7, config T, paste it. Done, you guys? So my key server at this point is ready to handle it. What do I do on the group member to set GetVPN up? Let's take a look. Now the group members. Let's start with R1. Again, phase 1, I still need to set up phase 1 with this guy, so I will copy this because I need it. It's the same parameters. The only thing is it'll point towards 17.7. So on the group members, I need to set up the parameters to set up phase 1. Why do I need to set up phase 1? So my parameters can be exchanged in a secure manner through the secure tunnel, which is done by GDOI, which is an extension of ISACM. So all the parameters still ISACM, but internally it's going to use GDOI. Clear so far? Phase 1 okay on the group member? Generally, what do you do on phase 2 or step 2? Generally, when you do IPsec, what do you do on step 2? The transform set. Do I need to do it over here? No, because it's going to be coming down from where? From the key server. The next step would have been the ACL. Do I do that over here? No. Why? Because it's going to be coming down from my key server. So what do? I need to now go in, skip those 2 steps. I'm going to configure GDOI to point to the key server. How do I do it? Same command that I used up here. Any name. I'm going to purposely give it a different name so that you guys understand the name is locally significant. Well, what needs to match what is actually sent to the other side is the identity number. All right, everybody okay with that? Now, where is the key server? Remember over here I said server local. Here I'm going to specify server address IPv4. This is how I know which is my key server. So in my crypto GDOI group on the group member, all I do is I identify myself, my group number, and I point towards the key server. Good so far? Next, configure a crypto map. Very different over here. Does the identity number have to match R7? Yes, that's the identity. That's the whole thing. The purpose of the identity number is to make sure the group members identify themselves to the appropriate group on the key server. So all the group members will identify themselves as 111. So it has to match. The name doesn't matter, the group name doesn't matter, but the number does. So in your crypto map, I give it a name, whatever you want to call the crypto map, CMAP, sequence number 10. Normally I do this, don't I? We will not advertise the IPsec policy in GDOI. Which IPsec policy? GDOI is, you'll see that in a second. In my crypto map, normally I say IPsec ISACEMP, right? That means I'm using ISACEMP for phase 1. Instead over here, I'm going to say GDOI. So when in my crypto map, when I say CMAP 10 GDOI, it knows to look for that group name. So it knows to do GDOI, not ISACEMP. Does that answer your question, Zahid? So rather than saying IPsec ISACEMP, I say GDOI in my crypto map. That's the one that switches it over, says, oh, I'm not doing pure ISACEMP, I'm doing ISACEMP with GDOI. And the only parameter that I need over here is the group ID. So group ID is used over here to map or attach the configuration of the server and the identity number to my crypto map. Because what I'm going to apply to my interface is the crypto map. Apply the crypto map to the outgoing interface. How? Interface, in my case, it's E0/0, crypto map, CMAP, or whatever you have called it. As soon as, coming back to, I don't know, somebody asked me a question of when does it do the actual pushing down of the key or the parameters. As soon as you apply the crypto map to the interface, the client will go and activate the registration towards the key server, which in my case is 192.168.17.7. The key server will respond back and say, this is your key, this is your transform set, this is your ACL. So as soon as you apply the crypto map to the interface, that kicks in. Makes sense? Somebody had that question early on. I don't remember who it was. Is it shared over phase 1 tunnel? Which one? What is shared over phase 1? The session key? All these parameters come over session 1. The session key, the what do you call it? The transform set, the ACL, all are sent down over the phase 1 tunnel. Generally, it would have just been the session key, but now I'm also sending down the transform set as well as the ACL. All right. So copy, and I'll apply it to my first router over here, my first group member, let's say R1. Now, as soon as I press enter, I want you guys to see what happens. says registration to 17.17. Actually, it says start registration to 17.17 for group ABC using the address of 10.1. The TEK, TEK stands for traffic encryption key, was updated, means it was downloaded. So this is your session key that was downloaded. Registration is complete. Now, if I take a look at my show crypto ISACamp SA, it doesn't say quick mode idle, it says GDOI idle. GDOI is your get VPN protocol. And if you take a look at your IPsec SA, your transform set should have been downloaded, and your ACL is downloaded. And the protocol that it used was UDP 848. So these are the steps. Let's recap the steps on the group member. Phase 1, simple phase 1, the way you would have done it. Step 2 is identifying your identity number for your group and who your key server is. Step 3, create a crypto map and link it up to your group using GDOI and apply the crypto map to the interface. Is it tough? Really simple, right? On the group member side, because all the configuration, the transform set, the ACL, all that type of stuff is done on the key server. Now at this point, if you take a look at R1, it says anything that is 10.1 to 10.1 should be encrypted. This is your session key to encrypt it. This is your transform set to encrypt it, correct? Do you remember that 10.1 to 10.1 was working earlier on before I did this? 10.1 to 1 from 10.1.1.1, it was working. Do you think it's going to work now? Okay, good. So if I do this right now, I am encrypting. I'm going to encrypt the traffic and send it. No, it is interesting traffic. Why? I'm going from 10.1 to 10.1. Okay, so if I look at my counters over here, they would be encrypting it. So router 2 is getting what? Encrypted traffic. He does not have a key yet to decrypt it. So he has no idea what the packet is all about. He's going to drop it. So that's why I'm not getting a response back. But I am sending a packet out. Oops. What if I ping 3? What's going to happen? Same thing. I am encrypting the traffic. So my hit counts over here will increase again. Good? Clear? You guys understand that? So how do I fix this? How do I fix this problem? Push it to the other one. Copy it. I don't need to change anything. Take a look at it. It's the same config on all the group members because all of them are pointing towards what? The key server. Do you think anything that needs to be changed over here? Everything is pointed towards the key server. So I can copy it, paste it to 2. But before I paste it to 2, what I'll do over here is I'm going to ping 10.1.3.1 works fine. I can ping 4, works fine. I will not be able to ping 1. Although my ping will go, he will send the ping back as what? Encrypted, so I won't be able to do it. So now to come around that, I will paste the config. As soon as I apply it, again, installs the registration is complete, installs the TEK stands for traffic encryption key, another word for your session key. Now let's take a look. Do you remember this ping? This was working. Now the same thing will happen over here. It's going to encrypt it. 3 and 4 don't have it, so they will not be able to decrypt it. But now, should I be able to ping 10.1? This guy. Now this should be working fine. Everybody okay with this? You guys understand what I'm doing over here? So now that you understand it, let's just speed up the rest. On 3, paste it, and 4, paste it. Now everything should be encrypted and pinging. Ten 1, 10.2, and 10.3. If I take a look at show crypto, IPsec SA, also on your key server, show crypto GDOI key server members. Shows you the members for this particular group. You have 10.1 which is registered, 20.2 that is registered, 30.3 that's registered, and 40.4 that is registered. So you can see all your group members over here as well. Everybody okay with this? That is GetVPN for you guys. What do you mean by what version of GetVPN? It is GetVPN. There's version 1, I guess. When they come up with 2, I'll let you know. Good so far. Everybody okay with this? You understand this? As I said, it's not meant for the public side. It is meant for MPLS VPNs. Is your MPLS VPN encrypted, Zahir? No, it's not. MPLS VPN, is it connecting you to the internet or is it connecting your private sites to each other? Private sites. So what do private sites run? Private addresses or public addresses? Okay, so they're running private sites, private addresses. They're not encrypted. Can I use GetVPN over there? Absolutely. That's exactly what it's meant for. It's meant to encrypt your MPLS VPN environments. It was designed specifically for that. Got it, Zahir? So this is for point-to-point or all time, any type of MPLS VPN, any type. Because As long as I have reachability between two endpoints, layer 2 as well, because what am I basing this on? I need to have end-to-end reachability. So as long as I have reachability, I don't care what type of underlying architecture that you have. This is the only one that has inner outer the same. Yes, correct. Emma, does that answer your question in terms of what is required to set up an MPLS VPN? I don't care what your technology is in the middle. As long as you can do full routing prior to me setting up GetVPN, I will be able to run GetVPN on it. Unfortunately, I'm doing this on, what do you call it? On my VM IOU. When I do it, let me think if I'm doing, if I do it on GNS, I'll show you the back to capture. But what were you looking for exactly? As that's what I just told Zahir. It was written to encrypt MPLS VPN networks. If you have an MPLS VPN network, it is not encrypted. It is clear text. It's still going through the service provider network with clear text packets. MPLS VPN just provides isolation from other customer sites at the service provider level. If you want to encrypt your data so that the people at the service provider don't read your data, encrypt it using MPLS, using GetVPN. This is the best scenario for for encryption. GetVPN for MPLS. No, this is something that you do on your side. It's not, GetVPN is not done by your service provider, it's done by you. As long as you have end-to-end routing, you can run GetVPN. Absolutely correct. Tariq, does that answer your question? As long as you have full routing, you can run GetVPN, but mostly run in MPLS. Mostly run on MPLS. Yeah, as long as you have reachability. Good. So that is this particular topic over here. We'll come back and do more stuff with it over here. All right. But before we do that, we'll take a look at VRF. I want to introduce this and then get into that. This is a very hot topic. This is something that you really need to know from the exam perspective as well. It is not part of the underlay. Underlay is a prerequisite. As I've been saying, what is the prerequisite for GetVPN? What is the prerequisite? Routing. Your underlay technology is routing. You need to have end-to-end connectivity. No, not private. End-to-end connectivity is a key thing. Well, if you're on the internet, then you won't need to, you can't have private, you can have public, but it'll still work on the internet. I think you guys are missing out on some of the things that I'm saying because these things is exactly what I've been pointing out. Read Om Prakash right here. It will work only on fully routed networks. Potentially can work on the internet, but only if you're using public addresses on the inside. Good. All right, so let's go ahead and take a break. It is close to 7 based on our. So generally asking any vendor limitations on this? Yes, Cisco only. So it's 7 o'clock. Let's take it till 7:15. When we come back, we'll take a look at this concept of VRF. It's not on the exam that you need to configure it, but you need to have complete knowledge about at least VRF Lite, not necessarily MPLS VPNs, but VRF Lite, basic VRF, you need to know how to do that, because our objective on the exam is this. But if you don't understand how a VRF works, you'll have issues with that. So when we come back, very important part of the class, the VRF, VRF aware, and the get VPN. That's where we're gonna end today. So 7 to 7:15 break. When we come back, 15 minutes. We'll take a look at this. Any questions, guys, about this, the configuration part of it? Let me save this. Okay. Day 3, 8/26. All right, guys, break time. Hey guys, ready? Everybody back? Give me the go ahead and we'll get started. I want to do one more thing in this particular configuration, and then we'll go into the VRF, which is rekeying. I want to knock that out because that way when we do the VRF aware get VPN, it becomes easy. One of the things is rekeying. What is rekeying? Somebody asked me a question earlier on in terms of when does the key get generated and when does it get downloaded. As soon as you apply the crypto map to the interface, the session key, which is a common key for all the group members, gets generated and downloaded. So let's say this is the key server. This is GM1. It generated the session key on the key server and downloaded to the group member. Now the lifetime of this key that was generated is 3600 seconds by default. You guys remember that from the last time round? It's a common key. So let's say 5 minutes later, second GM comes up. GM2, he gets configured and a crypto map is applied. The keys, he goes and registers with the key server. The key server will download the same session key. But now because it's been 5 minutes, this timer would have dropped down to 3300 seconds. 5 minutes would have been knocked off. It's the same key because it's the same session key. The lifetime started when the first group member registered. Everybody understand this app? Yes? You guys understand that before we move forward to the next thing? Everybody, come on, yeses please. That way I know you're there. Okay. Now what happens at 3600 seconds after the first one went out? So now let's say this has expired. Now there's two things that can happen. I would have to wait for the interesting traffic to come in because the crypto map was already applied and it would go ahead and then regenerate the key. Or another thing that you can do is you can set up what is known as rekeying, where on the key server, before the first session key expires, the key server will regenerate a new key and send the new key to everybody that had registered. This process is known as rekeying. All right, rekeying can be done two different ways. It can be done either sending the key based on unicast to all the registered devices, or if you have PIM set up in your infrastructure, you can also use multicast based. So when it sends it, it creates a multicast group for that particular set of the group for all the group members and sends it based on multicasting. But for that, you need your infrastructure to be set up with some type of multicast routing protocol like PIM. We're not going to have that over here. We're not going to focus on multicast routing over here. So what I'm going to do is I'm going to do it based on unicast. So I want to set up my rekeying mechanism based on unicast. How do I do it? What are the different steps that I need to do to set it up based on rekeying of unicast, in which the key server, before the key expires, regenerates a brand new key and sends it down to the device. These are the steps that you need to take. Number one. So this concept over here is rekeying on the key server. Step one, generate a RSA key pair on the key server to identify itself. So it knows that when the new rekey gets sent down, it's coming from the proper host. The way you do that is crypto key generate RSA. You can specify your modulo size, which is the size of the key, 1024, let's say, and the label. Label basically specifies the name of the key. Let's call it get VPN. That's just a label that I want to give it, a name. So once I do that, it will generate a public-private key, RSA key, that is required for doing rekeying based on unicast. So over here, I'm going to generate that public-private key, and the name of the key now is get VPN. I'm going to use this VPN in my configuration. Now over here, I need to go back and find out what the group name is, so I can go back into it. It was called sales. So copy it. I'll go into sales, server local. Over here, the first thing that I would do is specify my rekeying transport. The default transport is multicast, but it's not going to work because you don't have multicast routing. So I'll change my rekey transport, means when the rekey happens, I'm going to send it based on a unicast update. But rekey for the unicast needs the authentication, my pub key, the RSA, and whatever key name you generated. This is the key that I'm going to use to authenticate myself. To encrypt the key, I need a rekey algorithm. I'm going to set the algorithm based on any of the protocols that are available to me. I'll just use triple des over here. Okay. Optionally, you have the ability to specify your rekey lifetime. If you don't specify it, the default is 3600 seconds. I'm just going to keep it as is. So this way, I have basically set my rekeying to be based on unicast. I've set my key up based on the RSA key that I generated, algorithm I set up. Everything is taken care of. So if you take a look at this, this is your rekeying commands under the server. So I'll put them down for you. Step 2, configure the GDOI group for rekeying. So before the key expires, it is going to regenerate the key. GDOI group, I think it was called sales over here, and server local, and then you would, I could have done this up front. It's not something that you need to do later on. I could have done it up front. But these are the main things. Anything that's not listed over here was the default, so that's why algorithm is missing over here. Done? That's your rekeying, by the way. I can put a stop to this one. This topic is taken care of. Everybody okay with this? So I took care of the initial keying as well as the rekeying. Good? The next thing is generation of the session key same as perfect port secrecy? No, it's not. If you want perfect port secrecy, you need to set that up. There's a set PFS group and you specify it. The rekeying, no, it's not absolutely necessary. It just makes it more efficient. Okay. Now, the second topic for the day is VRFs. I want to find out how many of you guys are aware of VRFs. How many people are not? Let's put it like that. Okay. Some are, some are not. I'm going to shut this down for a while. I'm going to use GNS instead. to explain VRFs to you guys, I'll use 6 routers over here. Router 1 and 2. I'll put 3 down here, 4 over here, 5 and 6. Bear with me. I'm setting up a topology that I want you guys to understand VRF based on. I am going to connect my router 1 and router 2. I'm going to use 2 links, 2 serial links. Over here, I'm going to use an Ethernet link, F00, connect to R3, F01, connect to R5, 2 connects to 4 over F00, 2 to 6, F01. Now, think about these two being 2 buildings. Think about these two being 2 separate buildings or 2 different locations, 2 different companies. This is one company. I'll change the style, change the color over here. Too bright, man. Okay, duplicate, and I'll put this over here as well. So I have the orange company over here, and in the same building, there's another company. Different company. I'll change the color for them. Oops. Okay. So now I have 2 buildings, building 1 and building 2, connected via these routers. This is like it's a managed services type of environment where R1, R2 belong to the managed services company. They have provided the ability to the orange and the purple company to connect their sites to each other. But at the same time, these are private sites. They want to be isolated from each other. So one of the things that you can do on a router is you can split the router into virtual routers. And that's what a VRF is. It allows you the ability to break down a router into multiple virtual routers. Each router will be a separate router. Now, when you go into a router and you do show IP route, you see the routing table, correct? That routing table that you guys see is known as the global or the default routing table. At the same time, you do have the ability, if you want, to create other virtual routing tables on the same router. When you create a virtual router, you need to assign it interfaces that belong to that virtual router. By default, all the interfaces on a router are assigned to the global or the default routing table, whatever you want to call it. All right. So right now, if you look at all the different interfaces that you have, all of the interfaces will be in the global routing table. Well, what I want to do is I want to create a separate virtual router on router 1, which is specifically meant for the orange company. One interface at any given time can only be in one virtual router or in the global routing table. So what I'm going to do is I'm going to put this interface, the F00 interface, and one of these serial interfaces into the orange virtual router. I'm going to put F01 and S01 in a separate virtual router. So on this router 1, I'll have 3 routing tables, the global, the orange, and the purple routers. How do I do that? How do I actually create these virtual routers? Very, very simple. I'll go in onto router 1, connect up to it. If you take a look at router 1 right now, oh man, it had the old one, so I'll just get rid of them. So I'm on router 1 right now, and I want to create 2 virtual routers over here. One virtual router for orange and one virtual router for purple. So I'll say IPVRF, I'll call it Cust A, Cust B. Customer A, all right? IPVRF, customer B. A is the top one, B is the bottom one. Once I create the VRF, I'll go into my interface F00, which is towards the router 3, orange router, and I'll say IPVRF forwarding Cust A. I'm basically telling this interface that you belong to this VRF called Cust A. Okay? Similarly, I'll say interface S00 also belongs to VRF Cust A. So now this VRF has 2 interfaces. Similarly, I'll go into my F01 interface, which is towards the bottom, towards R5, and I'll tell it you're part of VRF Cust B. And the serial interface is part of Cust B. So right now I've created 2 virtual routers, each one with 2 interfaces. So basically, on this particular router now, which essentially is router 1, I have the orange routing table, which has F00 and S00 assigned to it. I have the purple routing table, which has F01 and S01. All the unassigned interfaces would be in the global routing table. The R over here is the global routing table. But right now I have 3 routers over here. How do I check these routing tables? If I want to check the purple, I would say show IP route. If I ended over here, it would show you just the global routing table. If I want to see a particular VRF, I would say Cust B. If I want to see the orange, show IP route. Cust A. Good so far? Everybody following along? So let's do the configuration now based on this diagram that you have. R3 over here. Let's set some IP addresses over here. I'll say this IP address over here is 10.10.10.0. That's the network. Okay. This IP over here is going to be .3 on that network, and this IP over here is going to be .1 on that network. Okay. See this link at the top? That's the S00 link. Between R1 and R2 for the orange network, I'm going to create 10.12.12.0. This being .1, so this is S00, which is going to be .1, and the other one is also S00. On the other side, it's going to be .2. Good so far? Similarly, I'm going to have another network over here towards the bottom. Can this network also be 10.10.10.0? The answer is yes. That's the whole purpose of creating the VRFs, is to segregate these two routers as if they're two separate routers. So on the same router, I have actually segregated into two logical or virtual routers. Each one would have its own interfaces. So this one will also have a .1 on this IP, but this will be in the separate VRF, the F01 interface. And this guy over here will be, let's say, .5. Because I have what? The two interfaces in two different routing tables, they actually can be the same address, different addresses. They're completely unaware of each other. Same thing over here. I'm going to put S01 in a separate VRF. So this network over here in the middle can also be 10.12.12.0. And this guy over here is also .2, but on a separate interface. On this side, again, I'm going to do the same thing. I'm going to say this is 10.20.20.0/24. This guy is .2, and this guy is .4. This guy over here again is 10.20.20.0, same network. Because these are different companies, I cannot control what their IP addresses are. So I'm purposely putting them as a conflict. Do you see that? So I have two completely identical networks, almost, connecting through the middle routers, the core routers, which are connecting them to each other, and I want to be able to segregate them. You guys understand that? So help me out. How do I create a VRF? Step 1, create a VRF and assign interfaces to it. On R1, IP VRF cast A, IP VRF cast B. Done. Go on to the interfaces. Interface F0/0, IP VRF forwarding cast A, interface F01, IP VRF forwarding cast B, interface, or actually let's do two interfaces of the same side first so you guys don't get confused. And then I'll do F01 and S01, both part of what? B. R2, identical. Create it and assign it. So let's just copy this onto R1. I think I've done that already. Let's do it on R2. Show IP VRF. Shows you the two VRFs, cast A, cast B, and the interfaces that are part of that VRF. Good so far? My VRFs are created at this point. Any questions so far? Yes, please. If you understand everything, please say yes, because I want to make sure that everybody's on the same page with this. Okay, now can we care customer and be on the same interface? Can we same physical interface? One interface can only be part of one VRF. You can create sub interfaces and do it like that. But one interface, let's say it's, even if it's a sub interface, S00.1, .1 can only be part of one VRF. But you can create two sub interfaces into it. All right, let's start configuring this so that now that we have the VRFs in place, we'll start with R3. Help me out over here. What do I do on R3? Let's run 10.10.10.3 as the IP address. I'll create a loopback over here just for the heck of it. 10.1.1.0 or 10.3.3.0. Actually, I want to put it as 10.1.1.0. I want to create that conflict as well. So everything is the same. Going to 10.2.2.0. So I'll copy 10.2.2.0 over here and make this as, this is what I want to do. Okay, so how do I go about doing it? R3, simple, normal. R3 is not aware of this VRF. Create VRF cast A, assign interfaces. Now, first, yeah, I've done that already, right? Created the cast A, assign interfaces. I've done that. That's this part over here, right? Step 2, we'll do the configuration of the other routers and then do the thing over here. On the other router, on R3, interface F00. This is normal. This guy is not aware of any VRFs and anything like that. Okay. Now normally I would run a routing protocol. Let's run EIGRP as my routing protocol over here. 10.0.0.0. That should take care of both the 10s. 10.1 as well as 10.10. All right. R3 done. Let's do our, not this one. Let's save this as well. Now let's do this guy over here. R5. 10.10.10.5, 10.1.1.0 on this interface. Let's configure that. Ten 10.10.5. Router EIGRP 100, no auto, network is 10. Good so far? Now let's do the other side, R4. Knock out the other ones, the ones that I'm not really concerned about. My work will be on R1 and R2. R4, 10.20.24 and 10.2.2.2. 10.20.20.4. Loopback 0, 10.2.2.2. And let's run the same routing protocol. 10.0. Knock that out. R6. 10.20.20.6. 10.2.2.2. You guys understood what I did? I ran normal routing on R3 and R4, R5 and R6. Now the fun part. On R1, first of all, I need to configure my interface towards this guy. Which interface is that? That's F00, which is already inside the VRF. You can check that. Show run interface F0/0. I'm already part of VRF A. So over here, normal assignment of IP, just like you would normally do. As long as it's inside the VRF, it's fine. No shut. Okay? Take a look. Show IP route. Enter. It's blank. But if I do show IP route VRF cost A, it shows you the routing table with that interface in there. So show IP route followed by the VRF. Good. Now if I want to ping it, if I do ping 10.10.10.3, it's not going to work. Why not? When I do my normal ping, it consults the global routing table, which is blank right now. If you wanted to ping properly, you would need to set up what? Tell it, hey, listen, check this. VRF to ping. Does that make sense, guys? Everybody understand that? Simple VRF stuff right now. Now, on the other side of our 1 is the S00, which is 10, 12, 12, 1 going towards R2. Let's do that part. S00, IP address 10.12.12.1. This interface was also part of my VRF. So that should also be in my VRF now. 10, 10, 10, 12. Okay, let's do the same thing on R2. S00, which was already part of the VRF. So all I got to do is set the IP. This was 10.20.20.2. Set the IP. Show IP route, VRF, cust A. So I've broken my router down into 2 different routers plus the global routing. So if I go over here and ping, again, don't forget you need to put the, oops. I didn't put 2. Yes, sir. Thank you. All right. So ping VRF cust A 10.12.12.1 should be pinging R1. My IP is .2. Or for that matter, ping VRF cust A 10.20.20.4, which is router 4. If I go to router 1, ping VRF cust A 10.10.10.3. So I'm pinging that. Good, everybody? You guys understand that? Now, I'll come to the second VRF later on, but let's do the full connectivity now between R1, R3 all the way to R4. I'm just focusing on the first customer A. I want to get R3 to communicate to R4. Now, R3 and R4 are running what routing protocol? Do you guys remember? I ran only one routing protocol right now. What was that routing protocol? EIGRP, correct? Yeah? Now, how do I run EIGRP on router 1? If I run EIGRP on router 1 like this, and I say network, when I say network over here, it is focusing on the global routing table. When you say router EIGRP 100, and I say network, it is the global routing table. Instead, what I need to do is I need to tell it, I want to run EIGRP for my VRF. So I'll just do this for right now. I can put any, autonomous system over here. Irrelevant. It doesn't matter. What matters is what you do inside your VRF. So the way you go into the VRF for EIGRP is using a command called address family IPv4 VRF and cust A. Cust A is specifying that whatever you're going to run for EIGRP, you're going to run it within cust A. Inside cust A, the first command that you put in is your autonomous system. So although my global autonomous system is 1, but the one that I'm going to run with cust A is AS100. And then I do my no auto summary network 10. As soon as I say network 10 over here, it should establish a relationship with R3. And now if I do show IP route blank, show IP route VRF cust A, this is VRF flight. Yep. Any VR flight is basically running VRFs without running anything or doing anything with MPLS VPNs, no BGP. Good so far, guys? Everybody okay with this? All right. Now I'm going to do the same thing on R2. Router EIGRP1, irrelevant. This is more important. Autonomous system 100, no auto, network 10. So now I'm going to have full reachability from end to end. So if I go to router 4 over here, I should be able to see the 3 network. This one doesn't have VRFs, it's just 1. So if I do a ping 10.10.10.3, I should be able to ping it. Or 10.1.1.1, which is behind R3, ping it. You can also do a trace route to see and verify that it's going to the right route. It's going to 2 to 1 to 3. Everybody okay with that? So let me write this down for your information, how to run routing. So the next thing, step 2, assign IP addresses to the interfaces, which is normal, but I'll do that anyways for you. R1, and I'm only focusing on the routers. Can it be VRF run on L3 switches? Yes, absolutely can. Absolutely can. So on our, can we use other interfaces for global routing? Absolutely, yes. The ones that are not assigned to any of the VRFs are in global routing, and you will be using them for global routing. So router 1 now over here, how did I configure it? Interface, what was it? F0/0. I'll put the full command over here, although this part was done already. Remember, this was done already, but then the IP address. Oops, this is wrong. I jumped to router 2 in my mind. Still router 1 and router 2. F00 is S00 over there is this. All right, step number 3, run a routing protocol in the VRF. And I'm going to do, what do you call it? EIGRP. You can run all the routing protocols inside the VRF, but I'm going to focus on EIGRP over here and then static routes. Address family. For right now, yeah, I'm just doing cust A. IPv4, VRF, cust A, autonomous system, 100, no auto, network 10. This would be on R1, and this would actually also be on R2 because it is identical in terms of its configuration. If you take a look at it, 2 interfaces each on R1, R2, and cust A. The F00 towards R3 and S00 towards R2, which is the router for the managed services. Good so far. So I do have reachability from where to where right now, from R3 to R4, all the way across. Clear? Now let's do the same thing between R5, R1, R2, and R6, which is another company, but there's 2 shared routers in the middle, R1 and R2. So what do I do on R2? This is F01 towards this 10.10.10.1, same address, but a different interface. Let's do it in Notepad. So on R1, this was customer A. What do I do for customer B? F01 is the interface. Customer is B. IP, I'm going to keep the same IP. Generally, you cannot have two IPs that are identical on the same router. It's going to complain. But because now they're on two different VRFs, it's okay. So my F00, F01 and S01 will have the same IPs as F00 and S00. And it's not going to complain. Why? They're part of two different virtual routers. So let's go to router 1 and do that. Okay. Normally, this would have been an issue, but now, because of the VRF, you'll see that 10, 10, 10, 1, 10, 10, 10, 1, two different interfaces having identical addresses. The reason it's allowing you to do that is because they are in two separate VRFs. Running the routing is also identical. I can actually use the same process for the other one. Guys, feel free to ask questions, guys. It's going to be the same. The only difference is this is customer B. So let's finish the router 1 part off. We did this part for B. Now we'll do the routing part for B. I did use identical IPs. Take a look. Public IPs, no. Public IPs you will not be able to, because public IPs would mean that every customer will have different IPs assigned to them from the internet, from the ISP. That's the reason you cannot use it, not because of a technicality in the router. All right, so that took care of what? Router 1 in terms of the interfaces as well as routing. Let's do router 2 for interfaces as well as routing. Router 2, the interfaces identical to the interfaces on this guy, just a different VRF. B, and this is 1. This is router 2's interfaces. Again, same interfaces as A. So again, over here, technically could have been a conflict, but it's not because of what? Two different VRs. So I can ping 10.12.12.1 from VRF A as well as from B because they're in two different interfaces. And then my routing, again, can be identical for 2. Established it. So now I'm running EIGRP all the way across. Good so far, guys? Everybody okay with this? Understand the concept of VRFs. In real world, is it done only at the service provider side? What I'm doing over here is not at the service provider side. Service provider, you do what is known as full-on VRFs, which is with BGP and MPLS VPN and all that type of stuff. What I'm doing over here is called VRF Lite. So this stuff you can do within your company. If you want segregation within your company, you have the ability to do that. So this part normally is not done at the service provider level. What you do with MPLS VPNs is what you do at the service provider side. Yes, we can. I'll show you how to do that. We need to do that over here. I won't do it between the VRS. We'll do it between the global and the VRF. I'll explain that, but later on. But before we do that, let's take this VRF concept and try to run a VPN over here. My objective, my next objective, by the way, in terms of what I wanted to cover, this is what I covered at this point. Good so far? Now I want to do this. I want to run a VPN which is aware of VRFs. Okay, how do I do that? And where do I do it? My objective over here. Remember, R1 represents this site, this orange site, customer A. A request has come in from customer A saying that any traffic going from 10.1 to 10.2, from R1 to R2 over this service provider cloud should be encrypted. So normally what would I do? What we learned the last time round, phase 1, phase 2, ACL, map, and apply. Agreed? Yeah? Almost everything is the same. The issue comes in your crypto, when you have the crypto ISACAMP key. The key is associated with an address. The address when you put the crypto ISACAMP key command is referencing the global routing table. Whereas in my case, it's not in the global routing table. It's going to be where? It is going to be in my VRF. And that's the thing I want to show you guys. How do you get around that? So to do that, you guys understand the objective over here. So the concept that I want to do over here is I'm not doing VPNs on R3. I'm doing it between R1 and R2. R3 has requested R1 and R2 to do the VPN, VPN between R1 and R2, the service provider cloud. VRF aware VPNs. Objective, R1 and R2 should encrypt traffic between 10.110/24 and 10.220/24 for cast A. That's my objective. All right, so let's go to router 1. Step 1 is phase 1 from last time. Do you guys remember this? Crypto ISACAMP policy 10 auth pre-share hash MD5 encryption, let's say, is triple des, group is 2. Then what did you do over here after that? Crypto ISACAMP key Cisco 123 address, and I would say 10.12.12.2, which is R2, right? This is where the problem comes in. When you say address 10.12.12.2, it is referencing the global routing table. It's not referencing the VRF. Okay, how do I get around that? Let me go ahead and show you that, and I'll copy it back over here. So on R1, I'll create my phase 1. Then I do crypto ISACAMP keyring, or keyring, and give it a name, whatever name you want to call it. Let's call it KR1 VRF cast A. So you create a keyring called KR1 for VRFA. Pre-shared key, address 10.12.12.2, key is Cisco 123. All right, that's the first thing that you do. Second thing, crypto ISACAMP profile, because I need to use this inside my crypto map. I'll call it prof A. prof.a, match identity address 10.12.12.2. VRF is, what was the name of the VRF? Caste. All right. Keyring was called KR1, and the VRF over here is Caste. Three things in here. Show run section crypto, and we'll copy this over here. So I needed to create this keyring and also specify my ISACEM profile, which later on links up to your crypto map. So rather than doing this part over here, I'll break it down. Phase 1 is fine. Phase 1, this is step A, ISACEM policies, that's A. Then you have a B step over here, create the keyring. That's this guy over here. And then you have a C step, create an ISACEM profile, which later on will be linked to the crypto map. All right, so that's what this is all about. Let's put spaces over here so you have, this is your first step now. The whole reason is because of the VRF. So you need to create a keyring that is pointing to the Caste VRF. You need to create an ISACEM profile which points to the VRF, specifies the keyring, and also the remote address. So this needs to match the, what do you call it? The VRF needs to be mentioned in multiple places. Once step 1 is done, then you can go ahead and do step 2. Step 2 is the same. Whatever you want to call it. Step 3 is your interesting traffic, which is also the same. Step 4 is also the same, almost, with a subtle difference. Crypto map, let's say ABC. I'll call it cost A, 10 IPsec ISACEM, match address 101, set peer, set transform set. What was it called? ABC, right? One extra command, which is this. Crypto map Caste, this particular crypto map will use the profile called prof.a, this guy. That's where you link it to that particular VRF to check the VRF based, what do you call it? The key. And the last bit is the same. Apply the crypto map to the interface. So in my case, the interface is S0/0, crypto map, Caste. So let's recap this. Normally, when we do a normal IPsec site-to-site VPN, we have 5 steps. Phase 1, phase 2, interesting traffic ACL, crypto map, and apply. I still have the 5 steps. It's just there's a slight change in phase 1. Rather than specifying your normal key, I need to create a key ring, which is attached to a VRF, and specify the address and the key in this particular format. Inside the key ring, I call it KR1. Then I need to attach the key ring to what is known as an ISAKMP profile, because the ISAKMP profile in turn will be attached to your crypto map. Inside your ISAKMP profile, you have the VRF that you want to do it for, the keyring that you have created in the previous step, and then you match the address of that keyring in the match identity statement. Don't forget to put the Caste VRF at the end. Then you do your interesting traffic ACL. Normally, you do your crypto map. Normally, the only difference is to that crypto map, you're applying that ISAKMP profile that you created called Prof1. And last but not the least, you crypto map on the interface. So I think we've done everything up to the keyring. I'll just copy the phase 2 part. The keyring portion was done. The ISAKMP profile was done. So I'll just do a phase 2, interesting traffic, crypto map, and apply to the interface. Now, I'll copy the same thing onto the other router. Router 2 for Caste. Again, I'm just doing it for Caste. So this stuff remains the same. Keyring name remains the same, but the pointer points to 12.1. Same thing in the ISAKMP profile, the pointer points to 12.1. Interesting traffic will flip. Now the interesting traffic will be from 10.2 to 10.1. Set peer and the profile will change, and you apply it. It's the same sets that you did on one side, you do it on the other. R2. ISAKMP seems to be there. Key name should be the same on both sides, or just the pre-shared key. The KR1 you're talking about? The KR1, Prof1, the crypto map name, all are locally significant. The pre-shared key needs to match. Good. To test it, I'll go to router 4 and do a ping to 10.1.1.1, source 10.2.2.2. If everything's fine, you should see pings over here. But how do I know they're encrypted or not? In order to do that, you go to R2, for example, show crypto IPsec SA. You will notice that I have 4 packets that were sent across, encrypted, decrypted. You also will see that the protected VRF over here, Caste, that is getting protected. And you have 10.2 to 10.1 as the interesting traffic. If I go to router 1, I can check the same thing. You can also do a show crypto ISAKMP SA and CL. There I go. Good, everybody? So what's the difference in terms of the setting up? Guys, if you have questions, please ask. The main difference is over here. So take a minute, analyze this, and tell me if you have any questions. Believe me, it's okay to ask questions. Guys, you better ask questions over here rather than having it something in your doubt in your mind when you go take the exam. Scroll down, you mean? 1 second. Questions, guys. Take a look at it and tell me if you have any questions about this. How do you apply the crypto map to the VRF Cast B? This Cast A? Couple of things. Number 1, S00 is already part of that VRF. Number 2, the ISAKMP profile